Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about distance word problems. The dreaded distance word problems, probably everybody's worst kind. But hopefully after this video you'll feel more confident in tackling this type of problem. In distance problems, you need to understand a fundamental relationship between distance, velocity, and time. And I've stated that here, velocity times time is equal to distance. So for example, if we had a vehicle traveling at a velocity of 90 kilometers an hour, and the time it traveled was 3 hours, we could find the distance. So distance is equal to velocity times time. Velocity is 90 kilometers per hour. Times 3 hours. The hours will cancel and the distance will be 270 kilometers. Let's look at the strategy for solving distance word problems. All right, in our first example, it says a car leaves Vancouver and drives at an average speed of 100 kilometers per hour. A motorcycle leaves Vancouver an hour later and travels along the same route at an average speed of 120 kilometers per hour. How long will it take the motorcycle to overtake the car? So lots of stuff going on, and people might think, well, I need distance. There's not enough information. But let's just take a look at this and I'll show you the strategy that I would use and I typically use for distance word problems. I would set up a chart, and that chart's going to have a row for each mode of transportation. The chart will also have 3 columns, one for velocity, one for time, and one for distance. And with this chart, in conjunction with this chart, I'm going to use the relationship distance is equal to velocity times time. I'm going to start putting my known values in. Really, the only numbers I have here are the car's velocity and the motorcycle's velocity. Next, I would determine what am I asked to solve here. It says, how long will it take the motorcycle to overtake the car? So that's time that the motorcycle is traveling. So that's going to be my unknown. So if that's my unknown, we need to then express the time that the car travels in terms of that. The car left an hour earlier than the motorcycle. So the car travels t plus 1 hours. Now that I have those 2 columns completed, I'm going to use this relationship to express distance. I don't know distance, and I don't even need to know distance in this example, but I do know that the distance the car traveled will be its velocity times its time. Similarly, the distance that the motorcycle travels will be its velocity times time. And that is what I'm going to make my equation about, is the distance. Now, it doesn't tell me anything about the distance. However, if they start at the same point, they travel the same route, and they meet up, that means that they've traveled exactly the same distance. And that's our equation. That's our statement of equality. So the distance traveled by the car is equivalent to the distance traveled by the motorcycle. And now we just solve this. I'm going to subtract 100t from both sides. I'm going to divide 100 by 20. And I get t equals 5. Let's do a check to make sure that that's the correct solution. The car travels at 100 kilometers an hour for t plus 1 hour, so 6 hours. So the car's traveled 600 kilometers. The motorcycle travels at 120 kilometers per hour for 5 hours. So it also travels 600 kilometers. So we've done our check. We know that this solution works. So we've finished. Let's see if it answers the question. How long will it take the motorcycle to overtake the car? Since that's what I let my variable equal, that's going to be the answer to the problem. So you can write a statement. It will take 5 hours for a motorcycle to overtake car. All right, let's try another one. Our second example says 2 cars leave Calgary at the same time, one traveling west at 110 kilometers per hour and the other traveling east at 120 kilometers per hour. How long will it take for them to be 500 kilometers apart? So in this example, we know both speeds. So the one going west is 110. The one going east is 120. The question says how long. That refers to time. Their time is going to be the same. That's going to be my variable. So west car will travel for t hours and so will east car. So they're both traveling that same amount of time. Now I can express their distance. Remember, distance is equal to velocity times time. So the west car, or the car traveling west, will travel a distance of 110 times t, and the car traveling east will travel a distance of 120 times t. That's the column that you want to make your equation about. What do we know about those two distances? Are they equal? Not in this case. We know that in this case, they have to add up to 500 kilometers because that's how far apart they are. So that's our equation. The distance traveled by the west car plus the distance by the car traveling east add up to equal 500 kilometers. So this distance plus this distance equals our total distance. Now we solve. So we've got 230t is 500, divide. So t is 500 over 230. That reduces to 50 over 23. And if we want to express it as a decimal number, which may probably make more sense in this type of application, we could round that off. I'm going 2 decimal places. It's going to depend on the situation. So time is 2.17 hours. Let's do a check. Let's see if that works. So the west car will be 110 times 2.17, and the east car is 120 times 2.17. Now I wrote down a rounded off value, but I'm going to actually use the value that's on my calculator that's more exact. When we add those up, it's 500 kilometers. So we know that the answer is correct. Now let's just make sure we've answered the question that was asked in the problem. How long will it take for them to be 500 kilometers apart? I did. That's what my variable represented. So it will take 2.17 hours. And we're done. All right, our last example is a little bit different than the previous ones, as you're going to see. Let's just read it first. A cyclist pedals to the store at a speed of 25 kilometers per hour and then home at a speed of 20 kilometers per hour. If the total time traveling is 45 minutes, how far is the store? So again, we're going to start by putting in what we know. We know the speeds. So going to the store, it's 25, and coming home or from the store, it's 20. We know the total time traveling, but it's not the time to the store or the time from the store. So you can't put that 45 minutes in there. We also need to change 45 minutes to hours. So 45 minutes will be 45 over 60 hours, which is 3/4 of an hour, or 0.75. I'm going to leave it as a fraction, and you're going to see why when I set up my equation. So that's our total time. Let's figure out what we want to let our variable equal. It says, how far is the store? So that's the distance. That's what they want to find out. So let's let D equal the distance to the store. And that will be in kilometers. So that's the distance to the store. That's also the distance from the store back home. So we're not going to make our equation about distance in this example. We know the two distances are equal, but we're not going to be able to solve anything if we say D is equal to D. What we need to do is make an equation or a statement of equality about time. How do we express time? We don't want to introduce a new variable. We know that distance is equal to velocity times time. Therefore, distance divided by velocity will equal time. So we're going to use our distance and our velocity to express time. So the time pedaling to the store will be the distance to the store divided by the velocity. So D divided by 25 will be the time pedaling to the store. Similarly, the time pedaling home will be the distance divided by the velocity home. And this is the thing I want to make my equation about, the time. I know that these times are different, but I do know that they should add up to equal 45 minutes or 3/4 of an hour. So that's what my equation is going to state. The time to the store plus the time home will equal the total time traveling with up to 3/4 of an hour. I have a fractional equation. We learned previously that in order to solve a fractional equation, we multiply through by our lowest common denominator. My lowest common denominator, 5 times 5 times 4, will be 100. So I'm going to multiply this side of the equation by 100, and I'm going to multiply this. When I multiply this side, remember you have to multiply every term. It'll be 75. Here, 25 goes into there once, 4 times into 100. This is like 100 over 1. 20 goes into there once, goes into there 5 times. So I have 4D plus 5D is equal to 75. So 9D is equal to 75. And D is equal to 75 over 9, which, if we round it off, is 8.33 kilometers. If I do a check, the first case I would have at the time to store being 8.33 kilometers divided by 25. If I kept the exact value, I would get the time in hours, and if I multiplied by 60, I would get minutes, which is 20 minutes. So this is going to be hours, which would be that many minutes. From store, if we took our distance divided by the speed of 20, will be 25 minutes. So you can see that our total travel time indeed will be 45 minutes. Have we answered the question? That's what we let our variable equal, the distance. So we have, and we just make a statement. Now that you've written the statement, you're done the problem. So in summary, when you're solving distance word problems, I highly recommend that you write a chart. It allows you to get a lot of the information out of the words into something that's more easily understood. Start off with putting known values for the individual modes of transportation. Whatever you know, put it in. That doesn't mean trying to put everything in the problem, but break it down to each mode of transportation. What do you know? What are you being asked? Set up your variable and then try to define the other mode of transportation in terms of that variable. Once you've completed those two columns, the known values and the unknowns, then you use your relationship distance equals velocity times time to complete the third column, whether it's this one or this one or this one. And that's the column you use to make your equation. Try ones that are similar to the ones that I've done, and then expand that to some that are slightly different. Practice and you will get confidence and skill. And when you're ready, we'll move on to the next type of word problem. Until then, take care.